So we are going to start out with a lightweight refresher on arrays and array lists, but really an overall introduction to data structure design. What is data? It's a collection of facts about which some conclusion can be drawn. If I tell you the temperature is 35 degrees outside, well, you might say, man, it's cold, but then it says right here it's hot. Well, there's some context. Are we talking about Celsius, Fahrenheit, or what have you? This is data. There's all kinds of types of data. There's textual, numeric data. We have audio data, video data, and so much more. What are data structures? A data structure is a particular way of storing and organizing data in a computer so that we can use it efficiently. And guess what? We've already studied what is arguably the most famous and common data structures, arrays. We have reviewed and studied arrays exhaustively here in Java, an array of integers. What is this? We have an assignment. Remember, we look to the right of the assignment. Yo, Java, make for me an array of int values. That's a primitive, right? An int values of size 30. And then save the address of the beginning of that array into this variable exam grades. We've covered this exhaustively, and that in fact is our first data structure that we're going to review. Here we have a depiction of arrays. We're going to quickly, in a couple of weeks, make it to linked lists. We have stacks and queues, our other data structures we're going to visit. We're even going to look at trees, heaps, and even hash tables. These are just some of the data structures that we will cover in this course. What is the goal or the objective? We need to organize data, but for what purpose, towards what end, so that we can have efficient, and that is the word, efficient storage of data, retrieval of data, manipulation of data. And so now we're left with a design issue. The challenge is to select the appropriate data structure for the given problem. Not every data structure is applicable for a given problem. You choose one data structure, and then it may be super slow, and you all of a sudden select a different data structure, and now you have the efficiency that you are seeking after. This is a major motivation in this course. Let's now take a look at the operations that we will be performing on our data structures. This might be a new word for us, traversing. It basically means step over every element within the data structure and visit it. Maybe you're going to print it or you're going to modify it in some way. So accessing or visiting every data element in that structure one time. Searching over our data structure, finding the location of a given value, inserting values into our data structure, deleting values from this data structure, sorting our data structure. We're going to learn many sorting algorithms towards the end of this course. Merging two data structures together in some fashion. We're going to see that in combination with our sorting algorithms. We can categorize our data structure based off of their memory allocation. Is it using a static or a fixed memory? This is the case with arrays. Once you make an array of size 100, for example, you cannot change the size of that array to make it smaller, of size 50, or double it to make it size 200. The size of the array is fixed once you create it. But we also have dynamic data structures where the size of that data structure can change. It can increase or decrease as needed, such as a linked list. We also can categorize data structures based off of their representation. We have linear data structures. This is your array, linked list, stacks, and queues. We also have nonlinear data structures such as trees and graphs. So what is the motivation here? Every data structure has a purpose, a reason for their being, for their creation, and the motivation behind it. Think about arrays as the one data structure we already know. What's the purpose of an array? Pause the video. Think about that. Why was an array created? Think about before we had arrays, something had to motivate that. Why would we have created an array? And so here we have an example. You want to store 5 numbers in a program? No problem. You make 5 int variables. No harm, no foul. Easy enough. But what if you want to store 1,000 different numbers? You could make 1,000 different variables. This would be huge brain. No, we'd be crying. That would be a disaster to make 1,000 different variables. So what would we do instead? We make an array. We use a data structure. An array is one of the most common data structures in practice. So what's an array? It's a data structure. It is a collection of homogeneous data elements, meaning elements of the same type. Examples, you can have an array of student grades. You can have an array of student names. You can even have an array of students from the OOP perspective, right? Where in fact, every element stored inside the array, instead of being a grade, right, which would be a float or a double, now every element stored within each cell of the array is actually an address that then points to or refers to an object, or in particular, a student object. Array elements, this is a new word here, array elements are stored in contiguous memory locations. What does contiguous mean? Consecutive memory locations. And don't think that's unimportant. We're going to focus on that. That is huge. That is one of the more important characteristics of an array, because it actually leads to what is the absolute best characteristic of an array, which is direct access. But I'm getting ahead now. An array is a static data structure, right? An array, we cannot grow or shrink that array. Its size is fixed once we have created it. So all array elements have to have the same type, and array elements are stored in contiguous memory. So an array of 100 integers here is going to be stored within 400 bytes of memory, because every int value, if you recall, is 4 bytes. So if I say, yo, Java, give me an array of size 100 primitive int values, Java will say, okay, you want a primitive int array where every int is 4 bytes, and you want it of size 100? Sure, 100 times 4, 400. Java will give you and will allocate for you 400 bytes of memory, contiguous memory, back to back to back. Every set of 4 bytes is right next to the previous set of 4 bytes. That is contiguous memory. Direct access is what is the single greatest characteristic of an array. What is direct access? Each element of the array can be accessed directly using its index, which means performance is very fast. It's instantaneous, where we can immediately access an index without searching, right? I can say, take this number 55 right here and save it at index 1250. And that happens instantaneously. And what facilitates this direct access? The answer is contiguous memory. So now what I want to do is draw out a detailed example of this, where we're going to get now pretty fine-grained and something we didn't see in a previous course. What does all of this mean? So if I tell Java, let's make an array of size, let's say int bracket, let's just call it x, equals new int of size 5. How many bytes did we just ask Java to make for us? Well, an int has 4 bytes, and we've now said give me an array of size 5, so we have just requested 20 total bytes. So Java is going to allocate 20 total bytes, and Java is going to partition those 20 bytes into 5 cells, which we always put this index, 0, 1, 2, 3, and 4. And now, what actually gets saved into this variable x, if you recall, The right side of that assignment creates this array, and what actually gets saved into X is simply an address. Here's X. What we save into X is an address, which I like to reference with an asterisk. And this address is simply the address of the beginning of that array in memory. So now I want to break down for you what this direct access actually means. Let's pretend that the beginning address in memory was 2000 right here. This is address 2000 in memory. And so therefore, what would be the address of this next cell right here? What would be the address of that cell? It would not be 2001, because remember, every cell is 4 bytes. So this would be 2004. And this address here would be 2008. The address here would be 2016. Oh, wow, I cannot. 2012. And then finally, the address of the last cell would be 2016. So I'm just making up this address where the first one is 2000, but therefore every next cell is simply 4 bytes farther down this contiguous set of 20 total bytes. Okay, so what if we then as a programmer typed the following? If we said that we want to save into index 3, we want to save the value 17. What actually happens under the hood? Why do we call this direct access? Because what happens under the hood, instantaneously, Java says we know that the beginning of the array is at index 2000. Not index, at address 2000. And now you're telling me that you want to go to index 3, which is 4 bytes for every single one of those indices. So that's going to be a total. Let's come over here. That's going to be, we're going to start at 2000, and then we're going to add to the 2000 12. Where did I get that 12? It was, we want to go to index 3 right here, and every index is 4 bytes, so 3 times 4 is 12. So very quickly under the hood, Java is going to take 2000, we're going to add 12 to it, and we're going to save this value 17 at position or memory address 2012, which is right here, and the 17 gets saved right there. That's way more detail than most have ever probably seen regarding arrays and where you save, or how under the hood it gets determined where you save a value. Let's do another one. Let's just say that we wanted to save at index 4. So X at index 4. So I just briefly paused the video to change the pressure adjustment here. Hopefully it's better, but we'd say we want to save at index 4. We want to save the value 87. Okay? So what actually happens under the hood? Java says, well, the beginning of the array is at index, not at index, the beginning of the array is at address 2000, and you want to save something at index 4, and every cell of the array is 4 bytes. So Java is going to say, well, we need to therefore save this value 87. We need to save it at memory address 2016. So this 87 right here is going to get placed right here at memory address 2016. This is what's really going on under the hood with respect to our arrays, and that's how we get direct access. So it's super important when we talk about what is the most important characteristic of an array. It's direct access. Well, what really gives you that direct access is contiguous memory. So accessing elements in an array is super fast. We can insert an element into the array instantaneously. But now let's begin to think about some running times, which, as we said, is a particular goal of this course. What if we want to add an element at the beginning of the array, and we don't want to lose or overwrite other values within that array? This would be a very slow operation. Imagine an array with 1,000 elements in it. Maybe the array is bigger than 1,000, but we currently have 1,000 elements. And we want to insert the next element at index 0, but we don't want to overwrite any of the other elements, and we want to keep them in order. What's the consequence? We need to actually shift over all elements one position. That's super slow. Now think if we wanted to insert a new element in the array at the next available spot. So if we have 1,000 elements from index 0 to index 999, we want to add a new element at index 1,000. That's instant, right? Because we don't need to shift over anything. It would be super fast. This is how we want to begin thinking to analyze, well, would it be just an insertion or would I need to shift and then insert? That's a big difference. It's not a big deal when it's an array size of 1,000, but what if the array size is 1 billion? Shifting 1 billion elements to insert one element, that is a disaster. What about removing an element at an array index? If we remove an element at the beginning of the array, it's going to be super slow for that same reason, because you don't want to leave a hole or a space in the array. So we would have to shift everything back one position. The same problem. But what about removing at the end of an array? That would also be fast because no shifting is required. We're also going to look at algorithms for searching through the array. That's going to come up really quickly. Depends on the algorithm. We're going to look at linear search and we're going to cover binary search. So conclusion of arrays here. What is the single best characteristic of an array? Absolutely, hands down, direct access. What gives you direct access? Contiguous memory. What is arguably the worst characteristic of an array? Shifting. Shifting is super slow, which is why the second data structure that we're going to cover, and really the first new data structure, is linked lists. Where we can avoid that shifting, we also then run into some other problems, and that's why we study this course, data structures, to look at the advantages and the disadvantage of every data structure. But for arrays, shifting is a disaster. Insertion and deletion into an array, while it can be instantaneous depending on where you insert or delete, it can also, in a worse scenario, require shifting of all elements in the array, which is a disaster. That is trash. Array lists are our buddy. What are array lists? Well, it fixes one of the major problems with arrays, which is the fact that they are static. Their size is fixed. You make an array size of 20, it must stay at 20. Well, Java gives us an ArrayList class, which can be used to store, in theory, an unlimited number of objects. The size can increase or can decrease, and there are many built-in methods. But I do want to remind you that although we have the appearance that the size of the array list is increasing and decreasing, in fact, under the hood, an array list is really just an array. So how does it increase or decrease? Because the default size of that array list is 10, and once you add 10 elements to that array, which is under the hood, and you try to add an 11th element, what Java actually does under the hood is it creates a new array. We then copy all of the elements, those 10 elements from the old array from index 0 to 9 to the new array, and then we save the new value into index 10 and we delete the old array. This is what's really going on, but it gives us the appearance that it in fact can grow and shrink. Here are just some of the methods that are available to us. We can add new values using the add method. We can add values to the array list. It'll automatically be added at the end of the list, or we can add at a specific index of the list and other things will be shifted automatically, which is nice. Java does that work for us. We can clear out the list, removing all elements. We can check if the list contains a particular element, so it's going to loop over all elements, searching for a given object. We can return the object at a particular index using this get method. We can return the index of the first matching element And there's so many other methods. Here, this is just a small sampling. As you know, what's best is to really just go to Google, go to your browser, go to Google, type in Java ArrayList, and you'll come to the official Oracle documentation for ArrayLists, which you see here. We have the class ArrayList. Here are the constructors where you can create an empty list with an initial size of 10. You could also send over a parameter of the capacity if you want a larger initial size. And then we have all of these different methods that are available to us. As I mentioned, we have this add method. We could add an element to our array list. We can add at a particular location of our array list. So let's look at some more details of this array list. The array list is known as a generic class, which means it really has a generic type. Well, what does that mean? That means that we can specify our own type when we are making an array list. For example, if you want to make an array list of cities, that would really be an array list of strings, right? So we have to specify right here string as, hey, this is the data type of the values that we're going to save in our array lists. And as you likely recall, this is redundant. You don't need to actually type string over here on the right side. You just simply use these arrow brackets instead. And so what I'd like to do, I say here study an example. Really, I just want to go code up an example that we're going to do live. So I have NetBeans open. I'm going to come here and type file, new project. Next, let's type arrays refresher. And I'm going to delete the package. I don't need any package, and I hit finish, and here we go. Why did that get moved down there? I don't know. Let's bring it up to here. Arrays refresher. Let's run this all as well. Let's zoom in. Okay, so let's make a new array list of integers, for example, and let's call it values equals new array list, and we don't need to type integer here again, right? We don't need to. Now, of course, the error is we have not imported this, so let's come over here. Let's add our import. Let's actually make this a wildcard import, so everything that we end up needing would be covered as long as it comes from that util package. And here we go. Now, it's underlined, as I mentioned, because this is really redundant. We don't need to mention this again. And now it's further underlined because we haven't used values yet. So now we have this array list of integers. I can say values.add, and I can add the number 10. Now values.add, and I add the number 8. Values.add, I add the number 13. And there we go. Let's see if we can just print this directly. What gets printed if I try to just print values? It gives me a depiction of the values that I've added to this array list. We can make an array list of string cities equals new array list. And again, I don't need to mention string here. That's called redundant. Java will recognize that and say it's redundant. Let's see, does it mention it here? Variable cities is never used. Let's just do cities.add. Let's add a city, Lakeland. And now let's come back. It should have mentioned that this is redundant. There we go. So now, oh, I misspelled. Let me fix that. Save. Now it's underlining it. And you'll see it says use diamond inference, and it gets rid of the string. Because this is redundant. You don't need to mention it again. So cities.add, we added Lakeland. How about cities.add, we add Orlando. And then cities.add, we add Tampa. There's so much you can do, right? We've covered this. I'm not going to go through all these different methods. That's only add. But let's now print it. We want to print cities. We're going to get Lakeland, Orlando, Tampa. Actually, it's already alphabetized. Let's actually put it out of order and remind you of something else. We can, now it's going to be out of order. We have Orlando, Lakeland, Tampa. We could then say collections.sort cities. And now let's print cities again. And let's see what we get. Lakeland, Orlando, Tampa. Now it's actually sorted. What if I want to check, hey, let's print out Does cities dot, here, I'll do this. Does cities, or cities contains the city Orlando. And we want to print true or false. So I would just concatenate here, cities dot contains Orlando. And it'll print true or false. And of course the answer is true. False? Why is it false? Oh, I can't type. That would be why. So now I run that again and it will print true. So cities contains the city Orlando. That's true. What about, does it contain the city Miami? And the answer is going to be false. It does not contain Miami. Pretty straightforward. You've seen this. This is just really a refresher, right? We have all of these methods. Clear, contains, you just saw. Is empty, to check if it's empty. Remove, we want to remove a particular object. Let's add Miami first. So cities.add Miami. And now let's go remove Tampa. Cities.remove Tampa. And then let's print cities again. And when we print this, we get Lakeland, Orlando, Miami. So this is just a reminder of not only array lists, but that we have all of these methods available to us that are super helpful, and we need to be comfortable with going to Java's website, to Oracle's website, and viewing the official Java documentation. So I want to wrap this up and not belabor the point here. More stuff on array lists. Here we have a slide for differences and similarities between arrays and array lists. Here's how you create an array. Here's how you create an array list. How would you access an element of an array? How would you access an element of an array list? How do you update an array versus array list? Or get the size of the array versus the size of the array list? Just something we need to get back into the practice of, because we're going to be using arrays all of the time. And what really follows here are just examples. How do you create an array list from an array of objects? That's kind of cool, something we may not have seen before. Or how do we create an array of objects from an array list? Interesting that those operations that Java gives that availability for us to be able to make those conversions. Finding the min and max in an array list. This is interesting. Just something that's part of the Java collections. You can get the maximum value of an array list. We can also get the minimum value of an array list. Super helpful? I don't know, maybe not. Something to be aware that it exists. Shuffling. We can use collections.shuffle to shuffle values in an array list, kind of like I just showed you collections.sort. And we're done. I'm ending here with a fail picture. I think it's a funny one. I don't always fail at cropping, but when I do. And of course, we have to have our daily demotivator from despair.com or bi-weekly demotivator. So possibilities. I imagine this accessories poster, what would it say? I don't know. Possibilities. The possibilities are endless as long as you dream and aspire to blah, 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 right? Well, despair.com possibilities, new paths will open before you as soon as you lower your expectations. That one is horrible. It's worse than horrible. It's horrible. Hopefully this has been helpful. Just as I mentioned, a lightweight refresher on arrays and array lists. Let's practice this. Let's make sure we type up some of those things. Maybe in your IDE, you play with array lists just a little bit. And then when we get together, we're going to now do some active learning and something cool on array lists. See you then. Take care, everyone.